Hello everyone, you are welcome to this revision class. This is GCE Advanced Level Pure Mathematics Paper 2, June 2021 session. And today we are answering question 3. This question is on trigonometry and is divided into two sections. The first section is a proof, and we have been asked to show that sine 3a plus sine a divided by cos 3a plus cos a is equal to tan 2a. The second question reads, given that f of theta equal to sine theta minus root 3 cos theta, express f of theta in the form r sine theta minus lambda, where r is a positive constant and lambda is an acute angle. Hence, find the general solution of the equation sine 3 theta minus root 3 cos theta equal to root 2. So we start with the first question. We know that the sine of a plus b is equal to the sine of a times the cosine of b plus the cos of a times the sine of b. We also know that the sine of a minus b is equal to the sine of a times the cosine of b minus the cosine of a times the sine of b. Let's call this equation 1 and we call this equation 2. These are compound angle identities and there are so many ways of deriving them, but we are not going to go that far. Let's end at this level. If we add these two equations, this is what we're going to obtain. So if you take equation 1 plus equation 2, here we're going to have sine a plus b plus sine a minus b, which is equal to, we know sine a cos b plus sine a cos b gives us 2 sine a cos b, and cos a sine b plus negative cos a sine b gives us 0. So this is what we are going to obtain. Now, let a plus b be equal to x, and this one, a minus b, be equal to y. If we add these two equations, this is what we are going to obtain. We know a plus a gives us 2a, b plus negative b is 0, which is equal to x plus y. And so if we divide both sides by 2, we are going to obtain a, which is equal to x plus y divided by 2. Now, if you take the same equations, a plus b equal to x and a minus b equal to y, and we subtract, this is what we are going to obtain. So we know a minus a is 0, b minus negative b is 2b, which is equal to x minus y. And if you divide both sides by 2, we are going to obtain b, which is equal to x minus y divided by 2. And therefore, if you substitute in this equation, we are going to obtain the sine of x plus the sine of y, which is equal to 2 sine, we know a is x plus y divided by 2, so we have 2 sine x plus y on 2 times cos x minus y divided by 2. So we have expressed this sum as a product, and that is why we call it the factor formula. There are 3 other factor formulae that we have, but I'm simply going to state them. You can prove them at your convenience. So the second identity states that the sine of x minus the sine of y is equal to 2 times the cosine of x plus y divided by 2 times the sine of x minus y divided by 2. The third states that the cosine of x plus the cosine of y is equal to 2 times the cosine of x plus y on 2 times the cosine of x minus y on 2. And the fourth one states that the cosine of x minus the cosine of y is equal to negative 2 times the sine of x plus y on 2 times the sine of x minus y on 2. So in the first question, we have been asked to show that the sine of 3a plus the sine of a divided by the cos of 3a plus the cos of a is equal to the tan of 2a. So we need to simplify the numerator using this identity and the denominator using this identity. So we can call this x and this y. So this is x and y for the numerator, and this is x and y for the denominator. Therefore, the sine of 3a plus sine a is equal to 2 sine 3a plus a divided by 2 times the cosine of 3a minus a divided by 2. And if you simplify this, we are going to obtain 2 times the sine of, 3a plus a is 4a divided by 2 is 2a times the cosine of a. Also, the cosine of 3a plus the cosine of a is equal to 2 times the cosine of 3a plus a divided by 2 times the cosine of 3a minus a divided by 2. And this is equal to 2 times the cosine of 2a times the cosine of a. Therefore, if you take the sine of 3a plus the sine of a divided by the cosine of 3a plus the cosine of a, we are going to obtain this, that is 2 sine 2a cos a divided by 2 cos 2a cos a, which is equal to, now if you cancel our common factors, so we are left with sine 2a divided by the cosine of 2a, and this is equal to the tan of 2a. So this is what we have been asked to prove. Now we take the second question, and in this second question, we have to express this function in this form. And to do this, we have to start by writing out the identity for r sine theta minus lambda. And we know that r sine theta minus lambda is equal to r sine theta cos lambda minus r cos theta sine lambda. And this is identically equal to sine theta minus root 3 times cos theta. So here we need to compare the coefficients of sine theta and cos theta on both sides. So on the left, the coefficient of sine theta is r cos lambda, which is equal to, and the coefficient of sine theta here is 1. So let's name this 1. And here, the coefficient of cos theta is negative r sine lambda, which is equal to, the coefficient of cos theta this way is negative root 3. And if you divide both sides by negative 1, we're going to obtain r sine lambda, which is equal to root 3. So let's call this 2. So now we have two equations, and we have to solve these two equations simultaneously in order to obtain r and lambda. And if I square both sides of equation 1, I'm going to obtain r squared times cos squared lambda, which is equal to 1 squared. And if you do the same with equation 2, we're going to obtain r squared sine squared lambda, which is equal to root 3 squared. We know 1 squared is just 1 and root 3 squared is just 3. So if you add these two equations, we're going to obtain r squared cos squared lambda plus r squared sine squared lambda, which is equal to 1 plus 3. Here, if you factor out r squared, we're going to obtain cos squared lambda plus sine squared lambda, which is equal to 4. But we know that cos squared lambda plus sine squared lambda is equal to 1. And therefore, r squared times 1 is equal to 4. So r is equal to plus or minus the square root of 4, which is equal to plus or minus 2. But we're told that R is a positive constant. R is a positive constant. And therefore, R is equal to 2. Now, if you substitute R equal to 2 in equation 1, this is what we're going to obtain. So we have 2 times the cosine of lambda will be equal to 1. And if you divide both sides by 2, we're going to have cos lambda, which is equal to a half. And so lambda is equal to cos inverse of a half, which is equal to 60 degrees, since lambda is an acute angle. And therefore, we are saying that f of theta is equal to r sine theta minus lambda, which is equal to 2 sine theta minus 60 degrees. Therefore, we are saying that the sine of theta minus root 3 times the cosine of theta is identically equal to 2 times the sine of theta minus 60 degrees. So this is an identity which is satisfied by all values of theta. We also need to solve the equation sine theta minus root 3 cos theta equal to root 2. But we know that sine theta minus root 3 cos theta is identically equal to 2 sine theta minus 60 degrees. Therefore, we can replace this with 2 sine theta minus 60 degrees. So we are saying that 2 sine theta minus 60 degrees is equal to root 2. So this implies that the sine of theta minus 60 degrees is equal to root 2 on 2. And so our principal value, or our first solution, is obtained by taking the sine inverse of root 2 on 2, which is equal to 45 degrees. Therefore, we are saying that theta minus 60 degrees is equal to 180 n degrees plus negative 1 raised to the power n times the principal value, which is 45 degrees. So if you add 60 degrees on both sides, we're going to have theta, which is equal to 180 n degrees plus negative 1 raised to the power n times 45 degrees plus 60 degrees. So this is the general solution of this equation. And we know that n is an integer. So for any integer n, we are going to obtain an angle which must satisfy this equation. So that is why we call this the general solution of this equation. So thanks for watching this video. In the next presentation, I'll be solving question 4. So please remember to subscribe to this channel and do not forget to turn on notification so that whenever I upload a new content, you'll be notified.